see if it's streaming. I'm gonna continue to do the poker tool today. I think I'm gonna start with the Rust thing though. I haven't thought about this too much since the last time I streamed, which was yesterday, I think. So I made some stuff here, but I haven't thought about yet, so I'm gonna have to think about it again to see. I think today before I started streaming, I was thinking about this stuff here, which is the calculation of translating the current action into the amount. Because I'm gonna receive the actions as percentages, I think. I'm gonna pass them around as percentages from the data structure that I have here. This data structure. So I have to convert them into the amounts based on the current pot. So this is the annoying part, to do the calculation for updating the amounts each time, based on the percentages, and for updating the pot as well. The calculation is gonna be annoying. And I'm also, I was thinking about yesterday, like, this is something that I'm thinking about doing after I do the poker thing, which is to create something. I'm going to use the network X and the visualization thing to create some graphs of the recursion based on the stack frame. Because it's something that I'm struggling to understand, and I'm not 100% sure that it's going to work the way that I'm thinking about it here. But I think it is going to work, but my concern is that usually when you do recursion, what you want is the return value, and then you use the return value on the other calls. So it goes all the way to the bottom of the function calls, let's say, and then it goes back to the previous ones that were not done, and updates them or finishes the execution of them with the return from the base case. And then from that return, it pops everything off. It finishes everything off. So the main concern that I have here is the whole thing about the infinite loop, or figuring out if this is gonna keep going forever because of the nature of the recursion. The thing is, I don't think that's gonna happen, like, because in this case here, I'm not gonna be using the recursion, like the return of the function. The return is just to stop the function from executing, and the base cases. And what I'm thinking about more is the whole flow of the execution to create the sequence, to create all possible sequence of actions, so I can add the nodes and create the structure of everything. So, and this is another concern, that even if it doesn't get into an infinite loop, it still creates the wrong structure because of the execution of the lines. So in my mind, I might be thinking that I'm going to create all the possible lines because of the way that it executes here. But then what can happen in reality is that it is only creating some of the lines and not others based on the flow of the execution of the whole thing. And it's really hard to think about how to debug this or how to test to see if that's going to be the case or not. So, but as far as I can think now, it seems like this path is the correct way to solve this, but I'm not 100% sure. Which is to just do the recursions and then do the loops based on the actions. So create heuristics based on the action, and then what kind of stuff is going to happen after each action, and then loop over the possible bets of that level, and call the function recursively. And that's going to take into consideration all possible situations. And then through each step of the loop, then I update the plot amount and the current action. And that's what is going to make it reach the base cases. But the thing is, as well, well, actually, no, now that I think about it, I can just put the fold at each step of the way. I just extend I'm just going to extend the bets that it has, the options, and put a call option and a fold option to each level. And that way it's going to hit those base cases as well. But the annoying thing here is that I have to do a bunch of if-else statements here. And that's the thing that I'm spending some time thinking about it, like what is the best way to structure everything so that I have the least amount of levels of if-else statements here. because I have to separate between in position player and out of position player each time, because it's gonna alternate between them, and I need to know which one it is, both to calculate the percentage of the amount from the percentage and also to get the bats from the data structure. And then I'm gonna have to and I'm doing this distinction twice here, one here and then one here. But I think I can't get away with this because I have to do all these calculations before I decide what actions is and before the base cases, I think. So far, because I need the current amount in the beginning and the starting point at the beginning of the actions, I think. Because those things are supposed to happen regardless of what action it is here. So I was thinking about putting them after the fold here as well, but then I'm not 100% sure because of the if-else, if and elif statements. So I'm trying to figure all of this stuff out. I think I'm gonna spend 1 hour and a half here. So I'm gonna do the Rust thing that I do sometimes, and then I'll go back to working on that. Oh, the other thing that is gonna be difficult is figuring out the highest bet on the flop. That's the other thing that I realized, and I'm not really sure how I'm gonna do it yet. So this is it's more difficult because there are several different ways that I'm thinking about doing. So, and this is always the challenge, I think, it seems, at least for me so far, is that there's usually several ways of doing the same thing. And then the nuance of which one to choose depends on the context of what you're doing, which is infinitely complex because the higher it goes on the scale of what the thing is gonna do, the more variables there are. So you can imagine if something really specific, then it's simple, but then if the purpose of what you're doing extends, let's say, or goes into higher scales, let's say, not sure if that's the best way to put it, the more different things you can do, let's say. So the context increases and increases the amount of variables, of ways you can do whatever you're doing. So it becomes harder to decide how to structure everything because you can change the purpose of what you're doing. So even though it seems like all the ways are correct for the current thing, and it doesn't really matter which one you choose, then in the future you might realize that because of the way that you did one of the functions, then everything else in the design is wrong because of the way that you structured. So this is the hardest part to figure out. But what I'm thinking about is that I'm gonna have to get the maximum bet of each street, bet or raise of each street, to increase the other bets on the other streets based on that, because that's gonna become the baseline, and I need to know that to create the nodes on the tree with the correct node ID based on the way that Pio works. So this is gonna be annoying, but maybe what I do is just create a tree, and then I'm gonna have to specify as well, I think, because the different nodes are gonna have. I don't remember if I removed from the node the streets. I think I did. So maybe it's better to specify that when I create this algorithm that I'm creating now, because I'm not gonna have a way to differentiate the nodes based on the street, just on the level that they are connected through the children. Yeah, so I need to create a baseline with the highest bet, and then because I need to format the bets in a string with the correct value, so I can later on navigate through them and create the simulation, or just change the values, update the values based on the simulation.
Fa.
Fa.
does,
Fisso.
Fisso. What's going on? Did I run from the wrong thing?
set, unchanging,
What the fuck?
3.
Set unchanging.
3,
3.
Desiderare.
Desiderare.
desire,
Aria.
Aria.
air,
Bene.
Bene.
well,
Anche.
Anche.
also,
Giocare.
Giocare.
play,
Piccolo.
Piccolo.
small,
Fine.
Fine.
end,
Mettere.
Mettere.
put,
Casa.
Casa.
home,
Leggere.
Leggere.
read,
Mano.
Mano.
hand,
Portare.
Portare.
carry,
Grande.
Grande.
large,
Compitare.
Compitare.
spell, words,
Aggiungere.
Aggiungere.
add,
Anche.
Anche.
even, also,
Terra.
Terra.
land,
Qui.
Qui.
here,
Devo.
Devo.
I must,
Grande.
Grande.
big,
Alto.
Alto.
high, tall,
Tale.
Tale.
such,
Seguire.
Seguire.
follow,
Atto.
Atto.
enact,
Perché.
Perché.
why,
Chiedere.
Chiedere.
ask,
Maschi.
Maschi.
men,
Cambiamento.
Cambiamento.
a change,
È andato.
È andato.
he, she went,
Luce.
Luce.
light,
Tipo.
Tipo. Kind. ok.
kind, of thing,
Spento.
Spento.
turned off,
Bisogno.
Bisogno.
need,
Casa.
Casa.
house,
Immagine.
Immagine.
image,
Provare.
Provare.
try,
Noi.
Noi.
us,
Di nuovo.
Di nuovo.
again,
Animale.
Animale.
animal,
Punto.
Punto.
point,
Madre.
Madre.
mother,
Mondo.
Mondo.
world,
Vicino.
Vicino.
near,
Costruire.
Costruire.
build,
Se stesso.
Se stesso.
himself,
Terra.
Terra.
earth,
Padre.
Padre.
father,
I'm gonna put some music, I think. Now, let's think about this. So the first thing that I was thinking about is removing this condition here and putting outside here. So I think I'll focus first on the whole raising thing or converting the bats. So what I was thinking about is gonna be a raise. I have to check if they're first I have to check if they're the length of this. Because then it's gonna throw me an error if I try to get the true previous values, if the length is 1 obviously. So I need to check for the length. But the difference between the way that I'm doing here and the way that I was doing before to differentiate the actions is that here I think I'm not gonna make this equal to 0 after each street. So after the first street they're always gonna be greater than 2, I think. Oh, unless it goes check, I think. No, but even if it goes check, because I'm gonna append all the actions here, and I'm gonna append as a dictionary, so I know from which player the action came from. But I'm not really sure if that's necessary either. Maybe it's just better to append the action. The way that I thought is that I can get the which player it was based on the index, but I think that's a little bit more shaky, let's say. It's more concrete if I specify the player And I'm not really sure. I think I need the player, but I'm not 100% sure. Maybe I don't need the player actually. Now that I think about it. I do need to know which player it is so I can get the bets from the data structure. But I think for the previous actions, it doesn't matter which player. I just need to know if there were bats or not. And I don't need to specify which player it came from, I think. So maybe I just do the value. Because what I need here is to know if the two previous actions were like aggressive actions or passive action. If either one of them was a call, then it means that... if the first one was a call, then it means it's a bet. This one. The current one. If the previous one was a bet, then it means that this is a raise, but it can be either a re-raise or the first raise. So I have to get the one that happened before as well. So those are the conditions, I think. So the first thing that I have to test is if this action is an aggressive action. So I'm gonna move this stuff outside, I think. But now that I think about it, I think it's better to just leave. Maybe I'll change later, but it's better to just put the value here. Trying to think. Oh no, I think I need to know because of the donks. That's what. I think that's the reason why I put here, because I'm gonna have to know what is the last player to bet on the previous street to classify a donk, I think. And this is where it gets complicated, I think, because I think I have to classify that on here somewhere. If the street is this part is separated by player, and then for each player I do. So it's gonna alternate between these two conditions here at each step of the recursion, I think. And it's gonna be a bunch of recursions and loops, so it gets really confusing. And I made a different file, I think, just to clarify what's gonna happen after each action, so that I know what kind of stuff to put here after each one. Well, let me think about the turn is the donk is a problem, because and this is the other tricky thing which I don't know which is better to do, like put the streets outside and then the players inside of each one, or put the players outside and then the streets inside, to determine the logic. Because either way I think I'm gonna have to repeat some stuff, I think. And then obviously what I can do as well is abstract this away to a function, but I think I don't want to do that. I just want to leave everything on this one. Maybe that's not good. So a donk happens when the imposition player is the last one to do an aggressive action, I think. And then in the first action, the outer position player bats. I think I forgot as well how I was gonna determine like the transition between the two. I think it's through a call or something like that. It's a heuristic, like if it is in position and they call. Yeah, there are certain situations. So if it's in position and they call, then it's always gonna go to the next street. If they call or check. So this situation is always gonna be one that changes the street. The issue was the outer position, but there's also some condition, I think. Like if they call... Yeah, if they call or check... No, if they... that's the thing. If they call and the previous action was an aggressive action, then it is going to go to the next street. Yeah, so the only instance where it doesn't go is when they check and the other player hasn't done anything yet. But let's say he's moving from the flop to the turn, then how I'm gonna know? So let's say they called and then they check right away. The previous action is gonna be a call. Yeah, but if the previous action is not a call, then I think I can determine by that based on. So every time there is a call for either player, he moves the in position. You don't need to test, but for the other position, it tests if there is a bet on the previous action. And if there was, then that means that it is the next street. So I passed the turn there. Then I think probably the donk is gonna come. The distinction is gonna come here. The classification. The tricky thing is when it's converting from the flop to the turn, because I'm getting the amount in the beginning. So that's where it gets confusing, because I'm using the previous bets to determine whether or not it was a raise or re-raise or whatever. Yeah, but I think in either one of the situations, then the previous action is going to be a call or a check. So it's going to end up working as well. Because here it doesn't matter the distinction, I'm only getting the value. So I think this was gonna work. So I get the value here, and then I worry about the classification there for the donk. Yeah, because the classification only matters to decide the flow of the recursions. And then the loops are... It's kind of like a merge between depth first search and breadth first search, I think. That's the way that you merged both, I think. Because depth first search goes in depth first, because that's what recursion do. The recursion tends to do. It goes deeper, like it goes on the y-axis, and then breadth first search goes on the x-axis. And then it gets complicated when you need to combine both of the two, which is what I'm doing here. So the loops go through the x-axis, and the recursion goes through the y-axis, and then through the movement it populates everything, I think. So I think I need to do like this, and then remove these conditions and put this inside of the other one. Current amount. So this means it's a bet if the current. If it's not a bet, then obviously I don't need to do anything. So. Oh, but it can be a fold as well. Yeah. So either other things are gonna be a bet. So let me think now. So if it is a bet, then it's gonna be this calculation here, which multiplies the action by the pot divided by 100 to get the amount. And when it's a raise, then I call the function that I did before. Just goes the other way around from percentage to amount. Yeah, so this means it's a check. Not a check, a bet. I think I'm not gonna make the distinction between... Yeah, but that's another issue. The distinction between donks and bats on the flop, because depends on the type of hand that it is. But I think there's only one instance where it's gonna be a bet, I think. And that's when But I think it's not worth it doing here. It's better to do it later. The distinction. But there's only one instance, I think, where it's gonna be bad, and it is when the player is 3-betting. So when they are the 3-bet aggressor, that's the only instance. So I have to classify when the hand is when it's a 3-bet aggressor, and that's gonna go in the beginning there of the classification of the types of hand. But I think it doesn't matter that much, because I think just the classification of between 3-bet and single raise pot is enough, because when it's a 3-bet, it allows you to put more sizes because the stack depth is lower. The stack depth to pot ratio is lower, so it doesn't take as much space and as much RAM to calculate the tree. So it allows you to put more bet sizes. So I can just put whatever the same amount of bet sizes for the bets or donks when it's a 3-bet pot, and it doesn't matter that much. So I can just do this later, I think. The classification thing. So what it means when when is 0 is gonna be the first action. And now I think about, this is always gonna be, I don't need to make the distinction here, because this is always gonna be the in position player, because the out of position is gonna act, and then I'm gonna append, and then the length is gonna be 1. This with 1. Oh, but I need to make the distinction so I can get the... No, but I don't need it actually, because I know it's always going to be out of position. So I don't need this, I think. Let me think. So it's always the top condition, because the player is always the in position player at this point. But this is tricky because I don't know, like that's what I mean with the whole recursion thing. Because the way that I'm thinking about it is appending the... Yeah, but I think before each... Yeah, but that gets very confusing because I'm not 100% sure. But I think before each recursive call, I append the current action to the previous actions. But then I'm not 100% sure of how it's gonna work. But I think it is gonna work. Maybe the best way is just to build and then test, and then I'll think about it. Yeah, I think a good way is just to build, then like I can build the tree from, if everything here works, then I can build the tree. But then the thing is, I'm gonna have to create the other algorithm to traverse the tree before testing. Yeah, but I'll figure out later, I think. So yeah, so here's guess the previous. So if the previous action is a call, is a check, then this is gonna be a bet because the current action is a bet based on the condition here. And if the previous action is not a check, then it means it's a raise, so I call the function with 0 as So if this is greater or equal to true, then I have to do the same thing here, I think. But I think I can't get away with... I don't need to do the same thing, but I need to get the previous true actions. And this one I think I need to separate between players. Because it can be any action, either the flop, turn, or river. So I do the same. Yeah, that's the thing that I'm not sure. It's how to optimize these conditions here, because I need to verify if either one of the... Maybe I use a R here. If either one of them is a check or a call, then it is a bet, I think. Yeah, but then to know if it's a raise or a re-raise, I need the distinction. Maybe it's just difference. Yeah, because I need to do the same thing that I did here. I'm just trying to think if there's a better way to, or what's the best way so I don't have to nest a bunch of if-else statements here. Because I remember seeing a video, I think, I don't know, remember, I think it's called Aesthetics, the name on YouTube. And he talks about that doing this kind of stuff is bad. You should try to avoid this and do something else. So I have that in the back of my mind, and I know that but I can't think about a way to decrease. I have to think about how to decrease to the best that I can do here, so that I have the least amount of if-else, nested if-else statements. But I can't think about it other way, because I have to make these distinctions here. So if the previous one... Yeah, but that's the thing, because... Yeah, so I have to check if the previous second one is equal to a call. Because that means it's a bet. Because if it's different, then it is a re-raise. So first I think I do the same here that I did here. Then I do this, I leave here. So I just copy this one from here. And this is a step that I could pass to another function, I think. Like maybe if I think about a way to create a function that allows me to encapsulate everything, then I don't need to do the if-else statements. I just pass to the function, and then the function figures it out, what happens. The reason why I'm trying to avoid that is because I'm gonna have to call this function inside of the other function, so I'm not really sure. But I guess this is what composition is about. So I'm doing more composition, but like it's because I'm using classes as well. It's really weird. I'm not sure how this should be classified. I also don't know if there's a way to do like trees like this without doing classes. What would be the more composition approach to creating trees? Because in my mind, you need to create I'm thinking about how would I do that on Rust. I think I would need to create a struct and then implement It's kind of like a, it's not really a class. But then how would you do the whole thing? Because here, I think it is more a composition approach to run one function inside of the other, I think. Because the function, but then it's like I'm coupling the new function with the other one. Not sure if this is good or bad. And this is what I mean why it's really hard to decide these things, because this is I think a great example, this function here that I created, because when I created that was for a different, wasn't for a different purpose, but I was thinking about the other file, and then it's hard to know what you're gonna use this function for. So like depending on what parameters you put on the function, then it might make it to attach to a specific file. And then if you want to use it somewhere else, then like maybe everything becomes worse on the whole design of the thing. Then you have to rethink about like if there's a way to recreate the function so that it allows you to have more flexibility when using the function on other parts of the code. But I think I'm gonna leave it like this for now. Maybe once I finish everything on this function, then I think about this process of creating other functions to try to make this better or less with all these if-else statements here. So yeah, if the previous one is a call, then it's a bat. The current one is a bat. So I did the conversion. If the previous one is not a call, and the previous before that is a call, then it is a raise. So here I would do this thing here. But this would be with the imposition, I think. No. Yeah, because the previous one is from the outer position, so I think this is correct here. And then I think I can put else because they're, well, maybe not. Let me think. Yeah, I think I can put else. So if the previous one is not a call, then it's gonna hit this condition, and then it's gonna check for. So if this is not true, then it means that the only other option is that the true, or it can be fold as well. That's the thing. So I think it's better to put elif here, and maybe here is better to put elif as well. Oh, but I'm already checking. No, I'm checking for the. Yeah, but if the previous one is a fold, then it's not even gonna hit this part here. So yeah, I think it doesn't matter. So I can put else. And then here I have to call the function with the other, the last raise, and then the one before. Yeah, I think this is correct. Current plots. I think the calculation of the plot, I'm gonna have to do it before each recursive call because it depends on the action. So I need to calculate the value of the action first. In the first iteration, it doesn't matter because this is the starting plot. And then all the other iterations, all the other recursive calls, I can do the calculation of the plot based on the type of bet it is, or the type of action it is. Yeah, but then, let me think. I might have to keep track of each. Oh, but I'm gonna keep track on the previous bets, previous actions. No, but I might need to create other two different lists, like I did on the other one, to keep track of the bets only for each player. So there's both that and the flop, turn, and river as well. That is the annoying part. Maybe I need to pass 2 flag variables to determine whether it's a flop, turn, or river. Oh, but I'm already passing the streets. Yeah, so I think this differentiation comes here. So maybe I can create the flop, turn, and river thing. And then I just do it based on... based on the condition, the heuristics for changing the streets is gonna hit different parts of this thing here. And then depending on which place it hits, then I append different actions to the different lists. So I create one for flop bets, then another flop actions, then turn actions, river actions, and other 2 different lists to keep track of the players. I'm not sure how it would be classified, like if it would be considered as a stack. Now that I think about it, creating these things. I think it is stacks, so creating different stacks so that I can keep track of what's happening for each thing, so that I can do so it makes it easier to do the calculations here. I just got off the stack. Yeah, it is kind of this mechanism of the calculations are passed through the stack and then the flow happens on the recursion. So I think this part is correct. Current pots, current raise, the raise percentage, which is the current amount. Or maybe not, maybe here is the... No, but it is. Yeah, I'm just updating with the new value, so I can use the same variable. And the previous action is the last raise that was made, and then the raise before last is 2 before that. So I think I do this, and then I do the same thing for when the player is the opposition player, just change the order there. And so this should calculate everything, I think. So from this I'm gonna get the current amount in actual chips depending on the stack. Effective stack. Not depending on the effective stack, depending on the pot. And then I can use the current amount to do the other stuff. So I think this part, as far as I can think. So if it's a bet, then it just gets the percentage. It just converts based on the size of the pot. And then if it's a raise, I have to call the function because it's more tricky. And if it's a re-raise, I'll call the function again. And the only difference between the two is the actions that I passed there. If it's a raise, then the raise before last is 0. Well, and I think this has to be integers as well, I think. But I can do the conversion later, I think. I think I just use the round function on the other, like on these parts here. Yeah, so now I think I should think about the pot size. Trying to think which one to do first, the pot size or the recursive calls, based on which action it is. And I think I did a file just to organize the actions. Maybe I created on a different thing there. Or maybe delete it. Hmm. Did I delete this? Oh, decision heuristics here. Yeah. That's the stuff that I was thinking about. So check comes after a check or a call. Bets come after a check or a call. So these two are the same. And then I can just extend like the heuristics for the decision determines all the possible actions that can be taken from that point. So I can loop over them and call recursively. I think that's why I did this. So now I have to think about as well the classification of when it's gonna change the streets, when is a donk, and when is a re-raise, so I can update the values of the pots, the size of the pots. I think what I need to do is keep track of each player's actions. I think I'll do on top here. There are the ranges. I think I pressed Ctrl minus and then I made everything, all the comments shrink. I didn't know that. It worked like that. Let's see, Control plus. No, it doesn't work. I don't know how I did that. So let me think how I'm going to calculate. I have to think which thing to do first and how to calculate the pots. I wanna do the pot first because it's the most confusing, I think, for me. Oh, if someone is calling after a raise, that's where it gets complicated. I have to look into the other function as well, I think. So I think here I had to do twice because I was separating based on the player. And because it's a different thing as well based on the previous bats. Because I'm separating by street. Trying to think if I can. I'm not sure if it's a good idea to use this function or the other one. The problem is this is the stuff that I talked about again, which is that this one I made it so that it accepts the actions for each player based on the data structure of the thing, so that's why I can't reuse this one on the other one. Unless I want to change this one, but then it changes everything else, that's the problem. I can change this one slightly and then just make it again and then use on the other thing. But I'm not sure if it's worth it. Yeah, so the situation where it's tricky is when there's a raise after a bet, I think. Yeah, a raise actually. Because the only difference is if there is a bet or not. So if it is a raise, then I have to subtract the highest last value of either player, depending on who is raising, to increase the pot by that amount instead of increasing by the value of the raise. Because the player already has some amount invested into the pot. But I think that's the only situation, as far as I can think. Everything else, you're just gonna be adding the value of the... Because if it's the first bet and a call, you just add the value of the call. If it's the first bet, you add the value of the bet. And if it's a re-raise, it's the same kind of thing. Because it doesn't matter how many levels you go, you just get the highest one, the highest previous one, and subtract by the current one, and then you get the value. So I can do this classification based on this thing here again. Maybe I should abstract this away to a function, because I'm gonna be doing this on the other one as well. Because I'm constantly gonna have to look to see if the length of this is 0, 1 or greater or equal to true. Because I wanna know if this is the beginning of the hand or later. Yeah, the only difference between the stuff that I'm doing here in this function is that this thing outside has the extra information of what player it is and the length of the thing. So I'm trying to think if it makes sense to change this function here. Because this one I'm not using anywhere. But the thing is that like this one is based on the other one and they are pretty much the same thing, just the variables changed. So I'm not really sure if it's a good idea to put this extra logic on this one only and then leave the other one the way that it is. I think it might make sense because the only purpose that I'm gonna have this function for is to do the stuff that I'm doing now. But maybe not actually. Because I have to think as well in a situation where I don't want to create the tree, I just want to update certain values of the tree, then maybe it's better to leave it separate. Because then that allows me to have more flexibility on this one. I think it's a better call to leave this one as it is. Because I might have to use it for that other situation. And then I just create a new function and then encapsulate this one onto the other one. Maybe I can turn this into a decorator. Yeah, I wonder if that makes sense or not. Because the principle is the same, what I'm gonna do here, I think. Just add some extra logic to this one. Hey, Articon. What do you mean, man? Oh, I forgot to expand this one as well. I'm just trying to figure out what is the best way to create a tree, a poker tree, based on all the decisions and bets of each player from this other data structure here. It's very difficult to do for me. And the whole reason why I'm thinking about this is because I'm gonna have to do this same check twice there. And this is the stuff that I'm trying to avoid. Maybe I just code everything and then at the end I think about... Because I think it's easier to simplify after you know everything, probably. Because the issue is if I simplify now, then there might be something that I have to do on the other one. So once I have everything, it becomes easier to know what variables I would need to pass for the function. So I think that's what I'm gonna do. But then it's gonna get massive. And kind of ugly because of all this nested stuff here. And the only thing that I need to pass there is the conditions, and then the logic is going to be different, because what I'm trying to think about is just how to update the value of the current pot based on the action, which is going to be the current amount. So I passed the conditions there. And which ones should I start first? Oh, in the river I have to remember as well that on this situation when it's in position and the river is going to be a base case. And before it was, the base case was here outside, but then I decided to do like this because then I divide by each street for each player here. But I'm not really sure if that makes sense as well. Maybe it is better to separate by street outside and then by player inside. But then the problem with that is that I'm gonna have to do more repetition, I think, because then on each part I'm gonna have to differentiate by in position and out of position inside of these things here. So I think by doing by player first, then it allows me to simplify everything that is gonna happen inside. So I think this might be better, but then it gets confusing because of the condition of the river. And maybe there's another condition as well. When the bet reaches the stack size, it's dealt with here, but I think, yeah, if out of position calls, I think it's similar to the donk case, the one that ends the line with the out of position. So it is only gonna end the line if the out of position calls and there's a bet before. Because the symbol for calling and checking is the same. That's why I think I need to do the distinction based on the action that happened previously. I think it's better to do it the same because then it's better to update because the node ID is gonna be the same. So I'm gonna put, I think I'm gonna start by the flop here, for in position, the one that I wrote down here already. but it's not gonna be. And now let me think. So maybe I need to convert for integer before, so I can test if it's or maybe just do different than call. Because they're already handling float here, so I just do different than call to represent a bat without having to check for the type. Because I think it's gonna be a float here, but I'm not 100% sure, after it converts to the amount. So it starts as an integer, which is the value of the percentage, and then converts to a float based on the calculations. And then here I convert to an integer again by using the round. But I can't convert in the thing here because then, or maybe I can convert here before I do the if-else statements. But I think I'm just gonna pass as converted. So as I do the recursive call, I pass as the round. So if it's a check, then I think about all the possibilities, and it's gonna be for out of position player. So now I have to look at the thing first. Let me write a comment here, I think, first. So either a check. Oh, this is incorrect as well. Oh, they come after the check or a call. So I did the other way around. Oh, but I can't do it based on this as well. Because the current amount, it has to be current action. Yeah, the current action is going to be the... but then... The thing is, the current action is only going to be a percentage in the beginning. That's another problem. Because on the other... Or maybe I can pass. No, but then what's the point of converting? So maybe it's better to do this stuff outside first. But then how am I gonna do that? Because I need... The problem is I need to know the size of the pot to do the calculation. And the size of the pot is updated inside of the function. But the issue is that if I pass... The first one that I'm gonna pass has to be a percentage. But the other ones are gonna be converted because it's the recursive call. Fuck, didn't think about that as well. So how do I deal with this? Yeah, I can't live outside. Because the issue is, obviously I can convert again, but then it feels like there must be a better way. I can convert again to percentage just to call the function again, but that it doesn't make sense to me. But I need to know, like I need to convert inside of the function because it's a percentage of the pot, and the pot changes inside of the function. That's the problem. So maybe I only convert, but then maybe it's dumb to convert them in the beginning. I should have thought about this before. Maybe it has to be better to convert them before I do the recursive call, because then like I convert them inside of the loop, because I'm gonna be getting the information from the data structure, and then each one is a percentage, and then by the time that I call the function recursively, I'm gonna have the the size of the pot. So inside of the thing, inside of the loop for each one, and then it's better to abstract to a function, I think, because I'm gonna have to do a loop for everything. So I should have started with converting, I think, before, or with calling recursively before. That way I think it makes more sense. So maybe it's better to update the size, no, but the size of the pod needs to be updated with the actions as well. So I think the better way is probably gonna be remove all of this stuff, putting inside of a function, and then inside of these checks here, which I'm branching off the decisions, while I'm looping through the actions, then it converts and get the new value of the pot and the value of the decision. That's what I have to do, and I have to abstract everything to a function, otherwise it's gonna get massive here, because each part. So that's what I'm gonna do. I'm gonna remove this stuff here for now. I'm just gonna copy and put inside of a function, not change anything, and then I'll think about the decisions, and then create the loops for the decisions, and then I think about a structure of a function that is gonna work for all of them. And is it gonna be static method or I'm gonna change anything? Oh, what's gonna be the name of this thing? I think I need to put here. Maybe update actions. And maybe I need to create another function to update the pots. So I create one with the convert actions. I'm gonna pass for now, and then updates pot size. Or pot, update pot. And I think pot is also gonna have to be a static method, I think. Because I'm not, or maybe not, because the current pot, the starting pot is on the self there. Yeah, so maybe it's not, yeah, I should do just starting pots instead of making current pot here. I don't know why I did this, because the purpose of the class is just to maybe, oh, but then I can reinitialize. Oh, but that's the thing, because the question here is depends on the way that I'm gonna do this. Because let's say I want to create a simulation first, and then after I create the simulation I want to update the values. But then I can just navigate the tree, I think, and get the bats. Like, I don't need to... I was gonna say that I might need the self-starting pot to be the same, or to cache the value somewhere else, if I'm gonna change here on this function, because then, if I'm going through the data and I'm updating the nodes, then it might be better to have the initial pot size, so I can do calculations again. But with the data, it doesn't matter, because I'm getting the actual value. And I'm also gonna have the value of the nodes, but I think I would do the calculation again, but then because I'm gonna receive the amounts and then I'm gonna have the pots. No, I'm not gonna have the pots, that's the thing. I'm gonna have the pot from the data. So maybe I can do this outside for each hand. So leave the logic of updating outside of this class, and then inside of this class, I just leave the traversal of the tree based on the whatever amount I get there. So I calculate the baseline, because I already created the other function for this as well. So I leave them separately. I think that way works. So I wouldn't need to update the starting, to keep the starting pots the same on this class, because I would separate the logic. If I want to update, just update the tree with the values of the data, then I do the calculation outside for the hand, because I'm gonna have those values, and it's gonna be easier because I already have the other functions to calculate that I made for this. So, and then all I would have to do that would be different from standard bats is just convert the values into the string format, so I have the node ID, so I can traverse on the tree that I created here, and then call the other function to update the hands for the range, which is going to create the cascading effect and update everything else. So I think I'm going to leave this. I'm just going to modify the self starting pots. Maybe I should change the name as well. I just put pot, because then if I leave starting pot, it's going to be confusing. So just put self pots on each one of them. I think it's Ctrl Shift Alt J to select everything. So now let me go back to thinking about this. So the current values, and then the thing is, I think, I was gonna copy this and move that to the other function for now. So I can worry about this stuff later. Yeah. Not sure if it's gonna complain or not. I'm just gonna put it like this. Then I'll change this once I have the logic for the rest of the function. And then I wouldn't do this stuff here as well, because I'm gonna do it on inside of each thing there. So let me think. So I have to think about if I have the current action. If the current action is a C, is either gonna be a check or a call. A call comes after a bet or a raise, and check comes after a check or a call. So I can make this classification based on the previous one. And this is the stuff that I mean that this is why it's challenging to create the function, the other function, is because the type of classification is going to change depending on the previous. But maybe I can create some heuristic after I create all of this that handles all possible situations. I think that's what I'm going to try to do. So here, first I'm gonna hard code this, and then I'll think about how to abstract everything to the other function, so I can just call the other function every time. And the other function is gonna be to convert the actions, and then I use the amount that I get from the other one to increase the size of the pots for the next iteration. Now that's gonna work, I think. So here I have to check if the previous action and it's going to be from the auto position player, because here is in position is equal, let's see. If it is, then it means that this is a check. And then after, that's why, because after I have to do this classification, because depending on which type of action it is, there's going to be different possibilities of what can happen next, and that's how you navigate the tree. So each node of the tree has the branches, and then the heuristics here are the branches of the tree. Yeah, so this, I have to do this because it is the distinction between a call. So call comes after aggressive, and then, yeah, I think this works. So what happens after a check? They can either bet or check as well. So in this situation, I'm on the flop, so I'm gonna loop. Maybe that's another, no. I can think about putting the loop, but I think for the loop, it doesn't make sense to put it on the function because I'm gonna have to calculate separately the size of the, or maybe I can do it on the same function, calculate the amount and the increase. But I think, for some reason, I think it's better to separate the two different functions. Like one to calculate the amount and one to update the pots. But I'm not really sure why I think this way. I think it's again one of the things about the distribution of how interconnected everything should be or how separated. And I think that's the gradient of object-oriented from composition. So it's just a spectrum that is going to change depending on the circumstance, which is infinite. So it depends on the design and the overall goal of the software itself, I think. And that's why it's so difficult to figure out. It's this very analogous to poker, where the more complex, the more nuance is going to be the change of frequency of distributions of the ranges. Because the context has an infinite amount of variables and then is a gradient of densities. So the decision to separate them would lead more to composition end of the spectrum, I think, because then it allows more flexibility, which allows for more chaos and potential at the higher level, let's say, depending on what the software is made for. And if you couple them more, if you make them together, then it becomes more solid, but it becomes more rigid. So it becomes more like an object. That's why it's object-oriented. So it's a spectrum of density, and that's the geometry. It's very interesting. I think the reason why is because it's analogous to the universe, obviously. It's the spectrum of the electromagnetic field. The composition that creates the geometry that you're using to update the system. So you're creating an informational system based on the configuration of the geometry of the electromagnetic field that's analogous to space-time. And that's the purpose of the software, I think. That's why it's always deviating from one side to the other. And it depends on the purpose of the thing, because then it's like you're mapping out the geometrical structure of what you're trying to solve. Like you're using an informational field to manipulate the structure of space-time through geometry. But and this is what it makes it difficult to decide, because then it depends on, like, and you can't predict the future, so it depends on what is the purpose of the thing that you're building. And I think there must be a correlation with data. I think that's the key to figure this out. I think to create a framework of what's the best software design is a correlation of the flow of the data, because the more data it has, the more potential it has, so the more composition approach. The more fixed, the more object-oriented, but it's going to be a distribution of the two, because the flow of information is a hierarchical structure. Or it converges to a relative hierarchical structure, because that's the entropy that determines the nature of space-time, I think. Which is always relative to the reference frame, and depends on it's interconnected to the distribution of densities. Yeah, but I think maybe it makes more sense to put them together, and then because I'm just gonna use them inside of this class here to build. Yeah, but I think it's better to leave them separately, because then is the whole thing about the data that I don't know what I'm gonna use after. So I think this is the implication of what I'm talking about. Because I'm gonna use this with the data as well, and the data can change, then I think it's better to be more flexible and leave the functions as separately as they can from each other, so that later on, if there's something that I want to do that I didn't predict, then I have the ability to use the different functions that I made, because they're not interconnected with each other. And that's why intuitively I think calling the other function inside of the new function that I'm gonna do is not very good, I think. So maybe we should figure out a way to leave the function separately and then call the other function outside of the function with the value that I gain from the new function that I'm building. That makes sense. Because that allows me to be more flexible. But I'm not really sure if that's possible. But I'm gonna focus on this first. So now I use the standard paths that I created there. And then I use the player, just the auto position player. And then now I'm on flop, so I use the street here. But I think, yeah, it doesn't matter because it is equal, but it's probably better to use straight. And then I use the bats because I know that when it reaches this point, it's gonna be bat, and then I'm gonna extend the check. Because the check is either gonna bat or check after this endpoint here. And then I have to think about if it's gonna change the situation. So I think this is dependent on this part here. Because it goes back to the thing that I talked about, where if it's out of position and if the previous action now is the imposition player. So if the action is a check, then it means that it's gonna change the street, I think. It's either a check or a call, doesn't matter. It's gonna change the street because the imposition is the last tracked. So in this situation, I have to make the street equal to turn or pass. So here I extend and just I loop and then I call the recursive with the new action. So I'm gonna see what stuff I need to pass. The nodes I didn't think about yet as well. I think at each step of the thing I'm gonna be adding like a node, because the purpose of the recursion is to add the children, so it goes in depth, I think. Like I said before, it goes in the y-axis. So each time you pass the call, before you pass the call, you add the child to the node. But then what adds the breadth is the loops, because then it's gonna hit the same point of that recursion as many times as you need, depending on the possible actions that it has. So, and that fills the list of the children in the x direction. So the loop and the recursive calls are a combination of the xy, and it's how it navigates through the structure. And then the stacks outside are used to update the heuristics of the movement. I think it's making a lot more sense in my mind right now. But the confusing part and the challenging part about the recursion is not so much this. I think is when it goes back, and also trying to understand like the whole flow of the thing when it goes back as well is really hard, because then it might mess up the order of things here. But I think as long as I add at the correct endpoints the children, then that's all that matters, because I'm not using the return statements. I think the order when it goes back it's only important if you're gonna use the return from the base cases to do something. The other thing that I think about is maybe I should cache the nodes. I like put them on a set, and then I would use the return from the base cases on that, because each unique line is going to be determined by the base cases. So the overall potential, let's say, of all the possible actions that can be taken on the tree are going to be determined by the node ID at the baseline, the base case. And then I can use the set to navigate later. So maybe I should create another variable in the class that is equal to a set and then determines all possible paths to the tree. Because that way I can use that to navigate instead of doing something more complicated, because then I can just do string manipulation with the node ID and I can traverse the tree based on that. I think that makes a lot of sense. But the only thing I'm not 100% sure is the whole thing about if it would capture all the... I think In my mind, it makes sense that it would, because like you only have the complete action once it reaches the base case, and then each base case is going to be unique because of the traversal, and yeah, because it's a slat. Maybe I'll create this now, and then I'll think about this only after I have everything done, because this is just like a cherry on top, let's say. It's not necessary, I think, because I can figure out another way to update the tree outside just by doing the code again, I think, or navigating through the children. So, but it might be more efficient to do it like this, because then it allows me to just navigate. I have a cache of all the possible lines, so I can check if I can create maybe an index. Maybe it's better to make a dictionary, so that when I'm going through the data, I'm gonna have the full node ID of the actions that we're taking based on the hand. And then if I have this map of the possible actions, then I can just go through the map and update the hands that way, the frequencies. I'm not really sure if that makes sense or not. I think I'm gonna make like a set here, but I'll think about this later. But it seems like an interesting idea. So here I would make the new node here at this point. Or maybe I should worry about that later. Poker nodes. Do this for now. The current node ID also, I was gonna do this on the beginning, but then I realized it's better to do it here. So just take the previous one and add the action. Would be current node ID, and then current action. But it's not current action because I'm gonna get the current amount. I get the current amount and then I convert to a string based on the correct format and the baseline. But on the flop, I'm not gonna need the baseline, only on the other ones. But yeah, that's how I'm gonna do it. Then I pass that value, whatever it is here, and it's gonna be the new node ID. And I'm gonna have to do this on the base case as well. So maybe it's better to put that on the function as well, like just a small function that converts the amount into the string format, because I'm gonna have to do this all the time as well. But that one would be different for. But then I can leave outside the logic that makes the difference between the turn and the river. Just add the baseline, or I can pass a flag variable that if it is a, or make baseline equals 0, and then if there is a baseline, I just add. So I can do the same function, I think, for all of them. Then current action would be the current amount. Current player would be the in position player, because, or the out of position player, because it has to alternate between the two. Streets. Then a pass turn. Maybe I'll make it equal there. I think I'm gonna do like this, so that is more easy, like it's easier to understand what each one is, and then I just remove the comment there. Current turn. Yeah, now that's the thing. I did the function as well. Oh, put the action here. The function for getting the turn, but that's another thing. I think here at this endpoint I would loop over the possible turns, and I did the function on the previous stream that gets all possible turns, self-create turns. So loop over the self.turns here, I think. Alright, self.turn. Maybe I should just change for turns. And the rivers are going to depend on whatever turn it is. So I'm just going to remove. I'm going to use the turn, or the function, the current turn, to remove from the self.turns. And then I'm going to loop over that. There's also the other complication of the memory. But then the memory thing is a separate thing, because then if it doesn't work because of the memory, I can just change the thing that I'm doing. Instead of creating the tree, I just navigate through the paths. So I think that the only thing that would change would be the structure of the recursion would be the same. No, but maybe it would be different. Yeah, but it would be easier, I think, because then it would probably be the same skeleton, let's say, but then I just do less iterations, because I can do the logic based on whatever node. I can construct the node ID first, I think. Again, instead of creating the whole thing, then update one path at a time, let's say. Only update one path through the function. Think about only updating one path, and then yeah. But then here, we'll call here, and then make current turn equals return. And then from this point, it goes there. I think I'll be right back. Actually, there's 3 minutes. I think I'm gonna stop here. I'm gonna do like some of this stuff off stream. I might come back today, or maybe not. I don't know. But what I'm gonna be doing after this is just what I'm doing now. Separating the actions based on the logic here. See which node, then I loop each one. And then I have to see what kind of stuff that I need to pass to poker nodes. And then the main thing that is gonna be annoying is the calculation of the current amount, because I have to take the action. And then also thinking about... Oh, actually, I'm gonna pass the action here right away. So here is gonna be different. Like here is gonna be the current amount that I pass here for the node ID, but then the action I'm gonna pass as a percentage. And the reason why is because it's better to convert. Like I need to have the percentage, because the pot is gonna be different each time, so I can't separate them. But because the pot changes all the time inside of this function, I need the bets to be in percentages based on the data structure. So I can't pass them as an amount. So that's why it's better to do it here, because here I'm looping over the percentages from the data structure, and then I'm passing them. But then in the node ID, I pass the converted version based on whatever function I build there to classify each thing. But I think the first thing I'm gonna do is create all the loops and all the possible different actions in the way that I'm gonna call recursively, so I understand what do I need to abstract into the other function. So it simplifies, so I can simplify as much as possible. And so I can understand, or think about how to create the logic that is gonna work for converting regardless of what situation it is, from the percentage, receiving the pot, and then from the percentage. And I think changing the pot comes after changing the amount, because the calculation always requires the current pot right now before the call. So first you calculate the amount, and then from that amount you do the logic to calculate the new pot. So those are the two functions that I have to create, I think, and they're going to be separate. And then I'm going to call those two functions at each point of this loop here and pass this information like this. And I think once I have that, then I think that is finished. Then I'm just gonna have to think about a way to see if this is gonna work or not. How to test this. And the other problem is then the memory, if it's gonna work or not, because it might take too much memory to build. So I might have to put some extra, but then I think I'm gonna do outside. Like to test how do communicate with Pio and then check the size of the tree to see if I'm gonna be able to create the tree or not from Pio, and then it might still give me problems, but then yeah, it's gonna be difficult to debug this as well. But let me think. After I do this, I think that I'm gonna have like the whole tree. Then to get the add lines is just navigating the tree and converting the node IDs to the actual values again to put on the add line. But then, oh, also I forgot, but I have to update the ranges as well for each player. So I have to do the calculation of using this function here, update the range, so I can create, and this is gonna come when I create the node here, because this node I'm gonna append as a child of the current node. So the current node calls the add child, passes the new node, and then I call recursively. Yeah, that's how it works. And then for the current node or the new node, the range is gonna be the range of the current node times the action range, which is just gonna be initialized as the 0 frequencies first, based on whatever action happens here. So which based on this action, so it's gonna be just a dictionary there. And then I'm gonna call the other function to create which is the create hand range. So make a dictionary, create the hand range, then make it equal to the action, pass that as the current range of this node here. Yeah, everything is becoming more clear though, so I think I can see the path. Let me think about, like, what do I do after I create this tree? I think I can test. The whole reason why I did this one first is so I could node lock. That's the thing. So I need the whole tree, and then after this I need to create a function, I think, that calculates the path based on the data. So something that updates the ranges, goes through the tree and updates the ranges based on the data. That's what I need to do. Then after I do that, then I can node lock. I go over the data, update the ranges, then node lock. Yeah, but then how would it... The process of node locking is also... Because how do I determine which path to node lock? Oh, I can do a bunch of other stuff as well to calculate the percentages and the relevance based on the data that I talked about before. And so that's but I'm gonna focus on this one now. So maybe I'll come back today, I'm not really sure. But if I don't, I'm probably gonna come back tomorrow or Monday. And there's a chance I don't come back today because I'm gonna work out, so... And I might work on this off stream, or maybe just leave for tomorrow, so...